All right, so these are just more examples. I'm just going to talk about each part of the exponential equation. So again, y equals a times b raised to the power of x. A is your initial value. B is your rate. So if it's greater than 1, it's going to go up. It's going to increase. If it's less than 1 but greater than 0, it's going to go down. And then x is just based on time. Okay. All right. So we have our first example here. All right. So it asks, does this function represent exponential growth or an exponential decay? So is it going to increase or is it going to decrease? All right. So how I know is when it's talking about the growth or decay, it's talking about the rate. So is the rate greater than 1 or is the rate in between 0 and 1? Well, I know this by knowing what is happening there. So it says 1 minus 0.9. So that's going to be between 0 and 1. So because the rate is in between 0 and 1, okay, this means it's going to be a decay. You can also look at the fact that it's going to be a subtraction sign. That tells you it's going to be a decay as well. What is your initial value? Your initial value is always in front of the parentheses. So our initial value here is 2,250. And then says, what is the rate of growth or rate of decay? So in order to know that, you just have to know what it's subtracting by. Okay, so it's subtracting by that 0.9. That 0.9 is our rate value. Okay, all right, so it's subtracting the rate of 0.9, but I want to know what that is in a decimal or a percentage. So just like I wanted to change a percentage into a decimal, I would move it to the left. So because I'm given a decimal and I want the percentage, I'm gonna move it to the right. So this is 90% decay. All right. So for this one right here, okay, does this function represent a exponential growth or decay? All right. So again, you're looking in the parentheses when you're wondering that. Okay. So because it's adding a rate of 0.04, this is going to be a growth. All right, the initial rate is in front of the parentheses, so that would be the 10. And then your rate of growth or decay, okay, is whatever it's adding. So it's 0.04, but again, we want that in a percentage, so we move our decimal to the right twice. So this is a percentage of 4% growth. All right, for this next one, okay, so if we're looking at this, it's asking if it's a growth or decay. So again, you just need to know, is it more than 1 or is it between 0 and 1, the parentheses. So the parentheses here, it's 1.05. So this is going to be a growth because it's more than 1. All right, your initial value is 2,000 because it's in front of the parentheses. Remember, your initial value is also your y-intercept. Okay, it's also your y-intercept. Okay, so, okay, what is the rate of growth or decay? So because it's growing, okay, I know that in the parentheses it should have been 1 plus our rate, okay, and our rate ended up being 1.05. So if I want to know what the rate is, I'm going to subtract this 1 that's with the rate. It's like solving for r. So when I subtract the 1, okay, I'm left with 0.05. Well, remember, when I want to change that decimal into a percentage, I move the decimal over twice. So our rate of growth was 5%. All right, last but not least, Right here we have, does this function represent an exponential growth or an exponential decay? So again, you're looking inside the parentheses. All right. So because that parenthesis number is between 0 and 1, this is going to be a decay. That means it's going to decrease. It's going to look like this. All right. Your initial value, again, is in front of the parentheses. And then what is the rate or growth of decay? Or rate of growth or rate of decay. So again, if it's a decay, that parentheses should be that 1 minus the rate. And then when we did that, we got 0.92. Okay. All right. So when we do that, all right, so we're going to subtract this 1. Again, you're going to subtract this 1. All right, but when you do that, you get negative 0.08. Well, that negative r, all right, we don't want a negative r, we want a positive r, so we have to divide by 1. Okay, when we divide by 1, it changes this to a positive r and our rate to 0.08, and then you move the decimal over twice. So our rate of decay was 8%. Okay, so essentially the same thing. You're just always, when you're wanting to know what the rate of growth or decay is, it just gives you a number. You just set it equal to the equation and solve for r. Okay, so you could have put this into menu 3.1 as well, and then you just move your decimal over twice.